All right, welcome to the Sweet Science of Fighting podcast. Today we have Aaron. How are you going, Aaron?
Yeah, good, James. Thanks for having me on.
No problem. So Aaron, based down in Tauranga, so he's also in New Zealand. So time zone was easy for this one. so, so
Doesn't
what?
always happen, does it?
No, not at all. So what I wanted to cover with this, you're deep into, I guess we could say, combat sports research, publishing scientific papers in that area. And I want to cover essentially all of it, a whole wide range, and how we can apply some of this knowledge to essentially the amateur fighter, hobbyist slash semi-competitive or competitive fighter as well. So maybe just want to give just a brief background about yourself, Aaron, then we'll dive into some of that research.
Yeah, cool. So I'm a research fellow at Auckland University of Technology and the Sport Performance Research Institute in New Zealand. Um, teach on a couple of really cool courses on enhancing muscular performance, and we're building an internship program, which is world leading, getting students placed in there and getting them jobs immediately out of it. So that's been fantastic. My research previously was usually around field-based movements. So sprinting, change of direction, how to improve the diagnostic capability of these tests, and then finding novel ways to enhance these capabilities in athletes. And I was lucky enough to have some, recently being exposed to some people at the UFC and over in China and in the US that have really wanted us to get into the combat research space. So the past couple of years, we've been connecting with them and digging deep into the research in combat.
Nice. We're gonna dive into that very soon. First, if anyone is actually interested in, I don't know, studying strength conditioning or sports science, wants to get into it, AUT in Auckland, New Zealand is legit. As Aaron says, they're getting interns and people getting into jobs and stuff like that. I studied through there. You're basically going straight into getting work experience from your undergrad. So it's worth doing. But firstly, your punching research. So do you want to maybe give us a little bit of background into that? Maybe how it relates to, or how any of the findings relate to maybe someone who's listening involved in any of the striking arts.
Yeah, well, this all originated a couple of years ago when we got connected with the UFC Performance Center there in Shanghai. And the head of performance at the time, Joseph Coyne, he wanted to understand some different ways to assess their athletes there. And he wanted to know what the best method was. So what we ended up doing is we ended up going into a really deep dive. My colleagues, John Cronin, Seth Linetsky, and Joseph went deep into the research, and we gathered everything we could, and we wanted to compile a list of what was valid, what is reliable, what are the different types of measurements. And this all culminated into a publication in SCJ where we just discussed the measurements and, talk about validity and reliability. There was so much research in the area, but the problem was that you couldn't actually measure across or compare between studies because the protective padding that was used on it, the methodologies were so different. So we wanted to take a practical approach and understand it. And what we came up with is we came up with a few different, Seth was the brainstorm behind this, and he came up with a couple of different ideas. So you can either measure force directly, so as in a measurement of force, like a strain gauge where it actually measures newtons, or you can measure it indirectly, think like an accelerometer. So you just use accelerations to convert it into force. The other thing that we wanted to know is that's really important is, are the devices inertially relevant to the sport? So are they on a pendulum? Is it a bag that you're punching similar than that would be in a gym? Is it a dummy, or is it a pad on a block on the wall? And so we took a deep dive into that, and we checked out what the reliability of it was and the validity of these, and we came up with some really, really cool information.
Do you want to dive into that for us?
Yeah, I'd love to. So when we're talking about reliability is, Bradshaw said, and Bradshaw and his colleagues established that cutoffs of a coefficient of variation of somewhere around 10%, and that ICC or an ICC is of less than 0.67 usually mean that it's going to have large variability. So based on that information, you need to know, all right, if you have less or greater than an ICC of 0.67, so that is a relationship, an agreement between sessions. That means that it's going to, you're going to have the same person. If you have an order of people punching, they're going to be in the consistent order every time. You're not going to have the person who's fourth jump up to first, the person's first drop to seventh. They're going to be consistent order. So the higher that relationship is, if agreeable between these sessions, that's good. The coefficient of variation is just your absolute consistency. So standard deviation and your mean, and you can just multiply that by 100, and that just gives you a very consistent measurement. So what we find is that these direct measurements using relevant targets, so yeah, again, think striking bag with embedded strain gauges, they have found that ICCs are usually around 0.95, and the CVs are below 6%. So very reliable, very consistent, very low variability when it comes to this. And this is both for the technical or technological reliability, so actually the measurement reliability of the device itself, and the biological reliability, that of the human performance. So you think that you come in one day and you punch a bag, you come in the next day and you punch it again. So biological variability. So these measurements are a combination of the two, which means that they can be used to understand both technical, ecological, and biological reliability consistently. When we look at the indirect measurements of inertially relevant devices or targets, you think striking bags with accelerometers built into them, what we find is the ICCs range between 0.95 and 0.98. So if they agree, you're going to have the same rank order consistency, and your CVs are extremely consistent, so about 1%. We recently have just been doing some research with an aqua bag, which is essentially it's a punching bag with a bladder filled with water. And when you strike the bag, the displacement measures comes down to a measurement of force. And they had the team over at UFC do this study. Well, first, we wanted to see whether it's valid and whether it's reliable technologically. So we set up a pendulum test, dropped different weights of pendulums hitting the bag, and check the consistency of it. It was, 0.99 ICCs, and CVs were below 1. So we know that the technological reliability or consistency of this bag is extremely low. So logical next step, let's go get some trained fighters to punch it. Send the bag over to UFC. They get a bunch of their trained experts over there striking this. We wanted to look and see, okay, single punch, that's probably important, but they're the experts. And what they wanted to know is they wanted to know how it measures up when they do multiple strikes. You throw in combos together, things like that. So with a single punch, CVs were somewhere between 7 to 11%, so kind of right on that cusp of it. And the ICCs were about 0.63 to 0.92, so a range of we'd consider acceptable reliability. However, once we start jumping into the multiple punches, what we see is that the variation goes up just a little bit. So we did both a 2-punch and a 5-punch combo, and CVs were between roughly 8 to 13%, and your ICCs range from 0.36 to 0.7. So the consistency or the agreement between them varied quite a bit. So single punches are a really good indicator for this device, but multiple punches probably need a little bit of work with the technology and extracting it. So
interesting. Yeah. There's a new paper that just got published this month or last month that it was looking at punching power in boxers, and they used a 3-minute I can't remember what they call it, a 3-minute boxing punch test basically to essentially replicate the workload in a round, but they used the wall mounted one. So then is that something then? Yeah, 3 minutes seems extreme to measure punching power, but I don't know, is that something that you've looked into as well, or is it just mainly you're looking at just pure one shot, take that, because that seems to be the most accurate?
Well, what we wanted to do is we looked across the literature, and most of the time it is a single or a 2 to 5 combo strike. The 3-minute rounds are probably good indicators of your aerobic capacity. But what we wanted to know is we wanted to know what the difference maker was in initiating that contact. So what is your anaerobic capacity? What is your glycolytic potential, right? And Seth Linetsky's PhD was about measuring effective mass and what happens with that snap, what happens with your ability to straighten up and become isometrically strong at that point of impact. And so that is more the approach that we took with it. And it's more reliable. You can think that if you had a reduced number of points of contact or limited variation in the limited movements is going to reduce the variation. So I'd be interested to see what the reliability of that test is.
Yeah, for sure.
And the validity of it as well.
Yeah, just for the listeners as well, when we're talking about reliability and validity, we're looking at reliability being able to replicate similar results each time. So obviously, if you're punching something and it gives you 1,000 newtons of force, and the next day you punch it again, it gives you 2,000, you're going to look at having skewed results. Then when we're talking about validity, we're talking about being able to actually measure the thing we're trying to measure. So just so listeners have an idea then. Secondly, Seth Linetsky's research is legit as he's actually got an article on Sweet Science of Fighting for your listeners about how to throw a powerful jab. So you guys can check that out too. And I'll be keen for you to dive into, we're going to dive into some of that, I guess, determinants of punching power as well. But is any of this stuff for testing punching power like commercially available? Can someone at home get something to do this? Or is this something that's going to take a few years to maybe develop to become part more of the mainstream?
Yeah, so there is an effort from there's been a boom from the technological companies to enable everyday fighting athletes to be able to measure their striking forces or their workloads. And right now, the easy one is the aqua bag. It's it just sets up like any other bag that you have in your gym, and you can use it to measure forces over a single or a workload over an entire session. Other things that you can use, they do have accelerometers built into boxing gloves, and they've also been measuring impact forces with essentially piezoelectric or strain gauges built into mouth guards. So these are all becoming more available to not only understand the impacts that you're giving, but the impacts you're receiving, if that is something that you want to be mindful of.
Those accelerometers that are in the boxing gloves, there's a lot of companies that have now created them for the general fitness market. They have how many punches you do in a minute, things like that. Are any of these accurate for, I guess, measuring punching, like one-off punching force, or is it just they're just there kind of more as a fitness gimmick as such at the moment?
Well, they will surely have a benefit of understanding the load, the intensities, the work that you're producing, but their accuracy of measuring a single blow is limited currently. I know that there are companies that over in Australia that have been getting better at it, and it's getting more accurate. They're using artificial intelligence to learn and machine learning to improve the algorithms to increase the accuracy of it. But currently, if you want to measure true one-off striking force, you should be using a punching bag that has a built-in strain gauge within it. Something that I think is important here is, they have wall-mounted ones pretty often in a lot of training facilities. But the problem with these wall-mounted strain gauges, that's just a piece of padding that's mounted against the wall, and you can use the kick or punch or knee or elbow or whatever it is you want to do. But their reliability, while the agreement is pretty good, usually above 0.9, the problem is their CVs have varied greatly. So depending on the device that you're using, a strike mate's usually pretty good. That's a pretty common one that you find out there. But there's other ones out there that have coefficient of variation of above 20%. Okay. So just be mindful of jumping into something that sounds too good to be true.
So there's like a lottery when you punch it, like those ones at the arcade.
Yeah, that's it. 3 cherries, good to go.
Nice. All right, let's dive into let's look at some more practical aspects now. So determinants of punching harder. So I guess everyone's looking, any striker there's looking for that knockout power, trying to develop it, whether it's in the gym, in the ring, whatever it is they're doing. So what is it that they should focus on within their training And I guess what is it that underpins a powerful punch?
Yeah, that's a really good one. So there's multiple components. Essentially, a punching force, that knockout blow is going to be both technically important, so where you land your accuracy of it, so that skill set, and also the amount of force that you can produce. And the amount of force which you can produce is the area that I know better, and the area that my colleagues focus on more. We're in the strength and conditioning space. So vertical force is a huge component of it. So we know that your ability to produce force into the ground will then summate and eventually end up at the fist. So it all starts from the ground. If you can build a good strength base from there, that would be a good place to start. And when we're looking at vertical force production, things like your weightlifting derivatives are going to be good, because it's not just producing high amounts of force, it's about producing high amounts of power, but that power needs to come with relatively high forces produced at a relatively high speed. Though, saying that, you can watch George Foreman knock people out left, right, and center, and he was throwing, a train instead of a rocket ship, So there's different ways to create that force, and it really comes down to the impulse. So how long you're producing that force, and the actual level of forces that you're producing as well. And other things that you can do to produce vertical force, plyometrics are fantastic. So if you need higher rate of force development, so you need to produce force quicker, plyometrics are going to be a good way to start.
Nice. I always get asked this, so I'm going to ask you this too. Best exercises then to develop vertical force or vertical power? It's obviously the most common one. There's obviously no best, but maybe exercises that you like to develop these qualities, ones you're fond of.
Oh man, I'm fond of so many. I love it. So there's lower body force. If we're talking about just vertical force here, because I got 3 more points on the training aspects there, which are going to be important for it. But when we're talking just vertical force, your loaded jumps. So I'd recommend any of your listeners who are interested in doing this, if you have access to a linear positions transducer, something that basically measures the speed of your lifts, if you can do a load velocity profile of a jump squat or a trap bar jump, whatever it is that you prefer, you have access to, and see how does your peak force line up when you're doing it at low weights versus high weights. And somewhere along there, you'll see a deficiency. And if you have a deficiency while jumping with heavier weights, that means you need to do more strength training. So more clean pulls. If you have a deficiency at the lighter weights, then you need to be doing more unloaded or light plyometrics.
For sure. And if anyone wants to learn more about that, I actually cover this in my Warrior Strength Training course on Sweet Science of Fighting. So you can actually jump on there and learn more about that too. And if you want any help with any of the program stuff, I've also got a program that has essentially exercises Aaron just talked about there too. So everything is there, resources for you if you guys need it. And I also want you, Aaron, to dive into those other 3 points you mentioned about training for that powerful punch.
Yeah, so the second one, as we know, you need to actually be able to make contact and strike. That comes with upper body peak force. That effective mass is essentially what's happening from the core to the shoulder to the chest to the arm extending, making contact, and that ability to stiffen upon impact. So first thing you can do to get greater upper body peak force is just do max strength training for the upper body. So you need to, as your listeners should be aware, just to be mindful of this idea around the length tension relationships of muscle. So we know that you're weaker when joint ranges, basically when you're contracted all the way, when you're concentrically contracted and joint angles are acute, you're weaker. As you go to extend a limb, your muscles become stronger at that longer length. So one of the best ways in order to accommodate for this is to use variable resistance, things like bands, chains. You can use pneumatic devices, weight releases, some things like that. So improving your ability, making sure that you're getting stronger across the entire length of the muscle is going to help with that impact force. Now, next one, effective mass here. So that ability to, not only do you need to be able to throw a punch quickly. Actually, you know what? I'm gonna switch my 0.4 with my 0.3 here. So
right.
in order, yeah, this will make more sense. Okay. So in order to throw a punch, that power, again, force and time. So you need to have a certain velocity component to it. So if you can improve the agonist-antagonist timing or contractions, you're going to lead to a greater force in the intended direction. Think of it, if you're trying to throw a punch, but your bicep is contracted, you're not going to be able to get as much speed because you're slowing it down. Your triceps and your biceps are fighting each other. Your chest and your rhomboids are fighting each other. So if you can turn off your bicep and you can turn off that rhomboid at the right time to increase the speed of the contraction for your triceps and your chest and your shoulder, then you're going to be able to create a greater velocity before you get to that impact. So one of the best ways that I learned from Gavin Pratt at UFC, he's the head of strength and conditioning there in UFC Shanghai, is this idea around oscillating resistance. So using bands attached to a kettlebell or whatever it is, and just doing small rep ranges where you contract and relax the muscles, okay? Contraction, relaxation training in order to improve that antagonist-agonist timing so you can create that greater velocity of the punch. Now, when it comes to actually making that contact, when we're talking about the forces that are going to knock somebody out, then we move to this term coined effective mass, all right? It's all good being able to throw a really fast punch, but when you hit, you just go limp and your body does not actually produce force through the intended object, then what you're going to end up with is just a really cool looking kung fu punch with no impact forces. And that's nothing against martial arts, but when we're talking about boxing and MMA, it is a much more of a force dominant component to it. So what you need to do is you need to be able to stiffen your body upon impact. So this isometric force capability instantly turned on, high rate of force development in an isometric condition will be able to lead to great effective mass and great punching forces. So you can use exercises such as landmine punches or isometric punches. These have been highly recommended. And it's a great way to teach the body how to stiffen upon impact. Yeah.
Nice. Yeah. For the listeners, if you check out episode 1 with Steve Pipe, he actually uses the isometric landmine punch for that reason too. And then in episode 2 with Graham Morris, he talks a little in depth as well with those oscillatory isometrics for that switching on and off. I really like that idea, and I love that, especially for sports that aren't so, I guess, grounded in strength, like combat sports stuff that have a huge speed component. Strength is, it underpins certain qualities, but it's not this thing like a strength sport where it's so important. So yeah, the oscillatory isometrics, and especially for those who've spent so much time, I guess, traditional strength training, right? They've come in, they've just been doing bench, squat, deadlift for how many years, and they've kind of almost like dampened that speed response. Those oscillatory isometrics are quite interesting. Do you have any other examples of oscillatory isometrics you would recommend other than that? I guess that band, what was that? The elbow flexion one?
Yeah, I mean, it depends on the sport that you're talking about or what you're looking for, but you can do it banded with a kettlebell deadlift. You can do it with a bench press, so you can hook bands on top of a bench press and just going up and down. You can use variable resistance. You can use bands with weights hanging off of it to get some sort of oscillation there, and that's going to be oscillation in a multiplanar fashion. So, when you hit somebody, they don't just move in a single direction, sagittal, whatever, or frontal. So they're going to be moving in multiple directions. So the ability to absorb and control through three-dimensional forces is going to be incredibly important there.
That's known as like the chaos bench press, right? With the
essentially.
Yeah, nice. And then with the oscillatory isometrics as well, there's a couple of ways that they can be done. So I know Dan Fichter and the crew, like Cal Dietz and them, there's a couple of ways that they they kind of all do them differently. So there's one way where you're pulsing, like you mentioned, like kind of quickly trying to get as many small pulses as possible. But there's also the method where you're looking to contract the muscle and then release and rebound back. So it's almost like I guess you could say a slower version, but it's still fast because you're tensing first and releasing.
Yeah.
Do you have a method that you like to use with those oscillatories?
Well, they're going to have they're going to work on two different mechanisms, right? So that contraction and immediate extension back into a contraction, what you're looking at there is a stretch reflex. So you think that if you're already strong, you already got good agonist antagonist timing, then the next thing is the ability to improve your neural system.
Yeah.
And so that we're looking for reflexes, your muscle spindles, your Buccal tendon organs, your things like that, probably more that muscle spindle action there. So as you extend it, the automatic coil back into a ready position is going to be important. That's what you can use that for. Your oscillating resistance is going to be more for your intermuscular timing there, your agonist, antagonist co-contractions. So whereas you might get intramuscular or the muscle spindle adaptations with the push, relax, contract.
Yeah, if anyone's a little confused with some of the terminology, check out my What is Strength Training article on Sweet Science of Fighting as well. Where would you place these oscillatory isometrics within a training phase? Would this be something that you'd have a fighter do all year round, or is this kind of like, hey, we're getting into fight camp, maybe like 4 to 8 weeks out, you'd put them there?
Yeah, so I need to go ahead and just put this disclaimer out there that I am primarily a researcher and I work with the people who are on the ground with it. So I'm coming from a more of an academic research background with this. So I've only trained some Taekwondo athletes and a couple of boxing athletes, but not at the highest level. So my programming guidelines for this are going to be rather anecdotal and arbitrary.
But perfect. It's still valuable.
The greater.
Still valuable.
Yeah. So, as most training goes, you train, you peak, you want to get closer to you want to peak as you're coming into the season or into the competition. So I would be putting these oscillatory isometrics or contractions into a closer to the time when you want to be going into camp or going into a match, because you would have already developed your contractile strength, your muscles are strong, you've already been doing some plyometrics up to that point. Then what you're going to be doing is, as you're shifting to more of a technical model, you're working on what's happening on the mat, what's happening on the floor, what's happening in the ring, or whatever it is, then you need to be focusing more on the neural. Plus, you got to be thinking that you need to be cutting weight, or you need to be mindful of weight at the very minimum. So your hypertrophy is out the window. You're going to want to throw that out for this period of time, because this is when you want to be neurally strong and maximally strong. So these oscillation resistance training would be a great place to put into your 4 to 6 week out phase. Your variable resistance training for peak power or peak strength. Your peak power would be 8 to 12 weeks. Your peak strength would be 16 to 20 weeks. So if you follow that model, that would be my recommendation.
Nice. That's clear for the listeners too. That's awesome. Is there any more, I guess, research you have or practical things that have come out of your collaboration with the UFC?
Well, one of the things that they were using a lot was this landmine punching test as basically establishing load velocity profile for a landmine punch. And what they wanted to know is A, is it reliable? And B, is it actually related to performance, to actual punching performance? So what they've done is they had a student researcher, a master student in there, and they measured the load velocity profile of it. And we were part of that project. And so what we looked at there, we do not have the findings quite yet because they are embargoed through the university. So I unfortunately can't tell you a whole lot more along those lines yet, but they will be coming out soon. And then what we want to know basically, does that landmine punch relate to your punching ability with the aqua bag? And there are promising results to this. So those of you and your listeners that do like that landmine punch or find it a useful tool, yeah, go ahead, keep doing it.
Okay, so we're looking at the landmine punch as potentially almost like a special strength exercise then for a boxer.
Not only is it a special strength exercise, but it can be used as an assessment tool for it. So if you do not have access to one of these punching bags with an accelerometer or a strain gauge in it, you can actually use a load velocity profile with a landmine punch to establish some sort of relative punching ability.
And you'd need like a gym aware for that, a learning position trainer
Yeah.
to do that. Okay, so if anyone's
Yeah,
listening
exactly.
and you want to nerd out, if you search gym aware, that would be the piece of equipment you would need to essentially assess your punching ability on the landmine.
Yeah, and should tell your listeners too that that is the exact setup that we used. When we did it, we need to make sure is that the line that is being pulled out to measure velocity is in line with the actual punch. So you go from a low to high position with that landmine punch. You think you go from the shoulder to about eye to forehead level. You need to have that line of pull similar. So if you put the gym aware on, I don't know, a box or something at about thigh level behind you, that's going to give you the most accurate reading. Otherwise, the arc of the line being pulled is going to manipulate the speed and change it.
Okay, I need a sponsorship from GymAware for giving them a shout out here. how heavy are you loading that landmine?
We were getting up to, I think it was 35% body mass.
Okay, so you were doing like 0%. Do you have a zero, like a unloaded measure?
We went, it was like bar 10, 15, 20, 25 kind of thing.
Yeah. Nice. Okay, interesting. Let's change tack a little bit to your judo research. So
Yeah.
maybe give us a little brief background, kind of what you're looking at there, and then we can maybe dive into anything that's practical from that too.
Yeah, so have some collaborators over in China who had a question. They wanted to know what the best training strategies were for improving judo performance. And one of the coaches from one of the national clubs over there reached out and he was like, hey, teach me how to do a literature review. So over the past year, we collected all the literature and we've analyzed it, and we found out that there's a lot of literature on it. And luckily enough, there has been some really good research that's come out recently on the influence of special training and high intensity training. So we wanted to look at things other than that. So your strength training, your plyometric training, things like that. So what we concluded was there are 3 different types of strength which are critical for judo, right? There is your maximal strength, the ability to manipulate your opponent once you get contact. There is the reactive strength, so the speed of actually engaging your opponent, and then the ability to produce power to throw them. And then there's this idea that you need to have strength endurance. So over a judo match can last anywhere between 1 and upwards of 8 minutes if you're going into golden point. So you need to have good strength endurance, but strength endurance primarily in the hands and the forearms, as assessed by the judogi pull-up test.
Okay, so how is this information then filtering down to the coaching or the training of the athlete? Is that influencing, I guess, the way that your colleague over there is now doing the training for the athletes? Or is there some thoughts that you have that kind of influence the way someone should train for judo?
Yeah, so it's been a really nice collaboration with them over there. And primarily what they would do is throw them through an incredibly high intensity training session. You'd think like 40 seconds on, 20 seconds off for 6 different exercises over 5 sets. And so any normal human would die, but they have gone through the system. So their work capacity is incredible. They're going to go into golden point and be able to last. But what we're finding is that a lot of matches, especially with these changes to the sport recently, means that you need to attack. You can't just score a point and sit back on your haunches and protect yourself and play defense. You need to actually consistently be attacking to score more points. And that ability to attack is directly related to your reactive strength. So this anaerobic capacity has become much more influential recently, as previously, a lot of people were looking at the physiology of the aerobic capacity, which does play a critical role. But if you can improve your ability to produce force quickly and your maximum strength capabilities, that has been found that it's really being beneficial to the new way that judo is being played.
Are you finding, I guess from your thoughts there, if you focus on and you prove maximal strength and reactive strength, that a byproduct of that, you're going to potentially improve some of that anaerobic capacity just because you're now going to be operating essentially at a lower percentage of maybe your maximum force capabilities within a match?
Yeah, 100%. That's exactly the thought.
Okay, perfect. So anyone listening out there, judo people, get strong. Reactive strength. So for reactive strength, we're talking mainly about plyometrics then, lower body plyometrics.
Yeah, I think you can be, another term might be explosive strength. So lower body plyometrics, upper body plyometrics, the ability to, you think if you've already initiated contact and you need to do a throw, the ability to push-pull or pull-push quickly is going to be extremely beneficial. So, plyometric pulling, pull-ups, plyometric rows, plyometric push-ups, in addition to your lower body plyometrics with your jumps or your horizontal jumps, your lateral jumps, your vertical jumps, and rotational jumps, because all of this is going to play a critical role in it. It's not just working in the sagittal plane. You're just doing vertical jumps is going to be good probably for early developing athletes who are just getting into it and who have very limited reactive strength index or power profile. But if you're more developed athlete who has been doing quite a bit of training over a while, then you might want to vary into some of those more advanced movement patterns.
Gotcha. Within the conditioning side then, because obviously you've mentioned how anaerobic power and capacity are highly important in that, essentially for judo. They're almost like, you could say determinants of success, because you're able to perform more throws, etc. Where does aerobic ability fit into this then? Because obviously if we spend all our time performing high intensity work only, then we're leaving generally aerobic capacity out of the equation, or very minimal. Is there room where someone should be focusing on that aerobic side to build that quote unquote base before coming to the anaerobic stuff, essentially, since you're looking at potentially opposite adaptations there?
Yeah, totally. So judo is pretty much a 2-to-1 to 3-to-1 work to rest ratio in competition. So the high intensity efforts are going to be beneficial for a certain period of time. But what they're finding is that you need to have good aerobic capacity to A, make it through a match, B, ensure that you have the capacity to recover within those breaks, lower your heart rate between breaks. And then finally, you're going to have multiple matches during a competition over a single day. So this ability to recover between matches. So it is critical to have a super good aerobic base in order to succeed at the greatest level. Sure, if you're a young athlete and you just happen to be stronger and faster and bigger and better than your competition, you don't need as well-developed base. But as you move up and your competition becomes more equal, you need to be able to recover. And that ability to recover is going to play both cardiorespiratory and metabolically. It's going to go within your muscles and tendons. So you need to have that well-developed base. And so probably aerobic training early, a really good aerobic training early in the off season. You can produce that base, then you have that foundation to work off of in order to make it more specific as you go into the competition phase.
What would be your go-to, I guess, exercise modality for, I guess aerobic stuff's pretty simple. You can keep that maybe on the mat, or you can do some off-feet stuff, whatever. But for the anaerobic power capacity stuff, when you maybe start getting a little more specific, do you have any go-to ideas for a judoka where maybe they would do some kind of throwing, oh, maybe using throws as part of their training, or are you looking at maybe off-feet stuff like on an air dyne or whatever?
Yeah, so there was a review that came out, I think it was either last year or the year before, and I can't remember the authors off the top of my head, but it was a really good one. And what they did was look at the specific judo training for the development. And essentially what that means is your randoris, your throws, your things like that, in order to build a base. And what they found is that the randoris in training were actually not to the level of what happened in competition.
There
So
was
you
a
need to throw.
jiu-jitsu study that did the same thing, that looked at rolling doesn't challenge VO2 max to the same level, or it doesn't challenge it enough to essentially develop a lot of aerobic qualities.
Yeah.
Yeah.
So what they recommended and what they found as well is that if you're doing throws, so I forgot what the bag is called, but you have the dummy bag, and if you're doing multiple throws, basically it's like doing a specific judo fitness test. If you're doing that as part of your training, it's going to help you technically, B, with the metabolic system that you need to do, and then if you can use that 2-to-1 to 3-to-1 work rest ratios, that is going to have transfer over. And that is in addition to the strength and conditioning training that you're already doing.
Nice. I like that. With those work to rest ratios, I don't know, it might be a little outside the research side and more towards, I guess, the program coach side, but I'll ask it anyway. You're looking at that 2-to-1 to 3-to-1 work to rest, but that's an average for the match. So obviously within matches, you're going to have variation, right? So you might have 1-to-1, 0.5-to-1, you might have crazy long, whatever. How then would you look to, I guess, program around that average, so you're not staying with that average and you're preparing for what they will call a worst case scenario, where you might have to repeat high intensity efforts with, hardly any rest, or, anything like that?
Yeah, well, as most people, listeners would be aware of, that you can train strength, power, endurance concurrently over a training phase. And when you're doing your blocks in the gym, you might have a day of power, you might have of force dominant power, a day of maximal strength, and a day of velocity dominant power. The same can be applied with your work rest ratios with the specific judo training. On your day where you have a high velocity, or your high velocity power day, you can be doing a work rest ratio of a 1-to-5, or a 5-to-1, sorry. And you can do on your maximum strength day, you might do a work rest ratio of 2-to-1. So you can manipulate, or a 1-to-1. So you can manipulate your work rest ratios depending on the quality that you're training that day, and where you program it within the day to ensure that you're not going to disrupt the strength gains. Because what we find, the most common thing that they find with concurrent training is that aerobic training interferes with strength training, and not so much the other way around. So making sure that you prioritize the strength power work, and then the aerobic work usually will happen later in the day. Or that's one thing to be very mindful of.
That's a good rule for people to follow if they're doing, for example, if they don't have technical training on a certain day or something, that to do your strength power work first in the morning, and then if you're going to do a conditioning, you do that afterwards or later in the day. Doing the other way around tends to not end well in the gym.
Yeah, that's right. And it's just like with sprinters, right? You go technique first, power second, endurance third. That formula works for just about every athlete who has to work along some sort of continuum of metabolic.
Yeah, exactly. Easiest way is fast to slow. Fast things first, and you go by speed below. Obviously, if you have technical training though in the morning, or technical training on that day, you want to do your technical training when you're freshest, and then go from there. What's next for you then in the research pipeline? Anything interesting you're able to share? Any maybe sneak peeks on some findings you've got coming up?
Yeah, so what we're doing right now is we are working through some training with a novel training concept called wearable resistance. So, you
Yeah,
know,
yes,
uh,
that's right.
yeah, right. Hey, so for those listeners that don't know, you can think of wearable resistance if you've ever tried to do some punching while holding, a couple of kilogram or 5 kilogram weight. That's the same concept. But what happens is you are actually, by holding on to that weight, you're tensing up muscles. So you're actually reducing the capability of punching performance. So this new technology came out about a decade ago and has been improving rapidly, where it's essentially like a compression garment, or it's like a fitted sleeve that you can Velcro on. And what you do is you can slap on weights moving from 50 to 200 gram increments. So you can eventually get up to about 1% on your forearms without it moving around. And you can do your training, you can do your combat punching, grappling, kicking, whatever it is, using this. And so Vecchio found a couple of years ago that punching with wearable resistance worn throughout the entire body, from legs, thighs, torso, and arms, improved punching performance more than just about any other form of training that we have found so far. Now, there are some limitations to that study, small sample sizes, it kind of went off. There's more research that needs to be done in that area. So that's kind of the gap that we're trying to fill now, is understanding, is there an optimal loading strategy to improve acute punching performance? So does wearing it on the anterior side of the forearm, or the posterior side of the forearm, or the shoulder, or the opposite torso, or the opposite leg and posterior side of the thigh, where is actually the best strategy for improving acute punching performance? And then what happens over a training phase with a progressive loading pattern that is individualized per person, so based off of percentage of body mass. And as what we found so far is acutely, from a lot of our research that we found with golf, it depends on where you put it, and that's going to affect where it goes. So what we found with, I know this is a this is a fighting podcast,
Yeah.
but just
Yep.
some of you probably golf a little bit too. But we found that if you load the front of the arm, so if you load, when you're golfing, you load the front arm on the front side, so towards the freeway. Yeah. There you got it. We get it. When you load that, what it'll do is it will close the club head. And
Okay.
if you load it on the back arm, the one facing back behind you,
You're at Slice City.
then it's going to open it up. So what happens with that is critical. Now, when we apply that same thing to punching, depending on your punching style, if you are one that prefers a rotate at the end of the punch, if you load medially, so the inside of your arm, it can help increase the speed of that punch. So
okay.
if you're trying to train to learn, if you don't have that capability quite yet, but it's something you want to do, that's going to help get you into the right position. Now, once you have figured that out and you're technically competent at it, then what you do is you load the lateral side, the outside of the arm. So what you do is you actually strengthen the muscles to turn the wrist over. So you load to correct the strategy first, and then you load to overcome that to get the muscle stronger.
Dude, I love this
So
topic so much. This wearable resistance, this is for sure the part of the future of combat sports training, or even most sports training. Like, you can't beat the specificity of doing something like this. And just to give the listeners an idea, tell them how it feels to you're essentially wearing nothing, to be honest, but how it feels to wear that compared to maybe holding 1 or 2 kilo dumbbells. That's a huge difference, right? Because you're basically holding kilos in the hands versus grams on the arms.
Night and day difference, right? So when we talk, you talk about the antagonist agonist timing. Well, you can actually, boxers wrap their hands and they want to be relaxed so they can punch at high velocities. Well, when you are tense through your forearm, that goes all the way up the arm and the rest of the way. So you cannot actually relax. So A, you're going to be messing up your agonist antagonist timing if you're holding something. Then B, we talked about load velocity, right? If you've already been strong, you already have high strength capabilities, but you need to increase your velocity. That's where you can really improve it by putting on, 800 grams, less than a kilo, like 2 pounds on your forearm. And the radius of that punch. So basically, when you're holding a dumbbell, it's at the distal part of your hands, the furthest place that it can go. But with this wearable resistance, what you can do is you can progressively increase it from, say, you want to wear a forearm sleeve. You can move the weight from just below the elbow early on. And as you get further and further into your training program, you can move that weight closer to your wrist. And that is an easy, simple way of progressing it without overtraining or getting pain or things like that. Because what happens is you find a lot of people that punch with it, and all of a sudden they got bicep tendonitis because they've been just cramped up trying to hold this weight while punching. So yeah, wearable resistance, we use it a lot with sprinters because we haven't found that it's negatively impacted joint kinematics or technique with the running style. And the other thing, which was really crazy with sprinters, is that when you put wearable resistance on either the forearms or the calves or the thighs, you don't really see much change in linear kinetics. So you think ground reaction forces aren't very much different between them. But what we find is that the rotational forces is bigger. And that's just because of the equation R equals mi squared. So your mass times your radius squared. So
interesting. Yeah. So if anyone's listening, essentially the further away you place it from that pivot point is the more force you're going to have to produce to overcome it, correct? Did I explain that at least part way? Yeah. Okay.
Yeah,
so
totally.
Yeah, we'll drop the company name. It's Lila Movement Tech you've been using, right?
It's Lila. They're a company based out of Malaysia. Joe Dolcetti is big into boxing, loves his combat sports, and he's done a fantastic job over there getting them off the ground and getting into some really, really cool research in multiple sporting domains.
Awesome. So if anyone's interested, maybe hit them up, let them know you heard on Sweet Science of Fighting so I can get a sponsorship from them. Now, I honestly, I love that. Like, to me, that's like the future of training. Obviously not for everything, but the future for part of training for combat sports, just because it's so practical how you can just stick it on whatever you need to do and you can improve forces without impacting technique. I also like John Cronin. He had a case study of a runner who, as he was losing weight, would put that weight back on with the Lila Tech when he would do his run. So, for example, if you're a fighter and you're 70 kgs, whatever, at the start of your prep, and as you go through your weight cut, whatever, you end up being 65 kgs, but as you go down, you add those extra kilos back on with the movement tech. So you're always training at 70 kgs. Then when it comes to the actual event, you're 5 kilos lighter. So that's like, I saw that and I was like, man, that is, the applications of that is just endless. Like, that seems like such a smart idea to give a go.
Right, because for as long as we can recall, we've been able to pick up heavy things. We've been able to jump on top of things, but we haven't had this ability to have sports-specific strength training in such an easily applied and practical manner. And I think that this is it doesn't take the place of those other training modalities. But it is just in addition to it. It is training high velocity strength.
Yeah. It's even something that you could almost pair in the gym as almost like a French contrast, or even within a complex, right? You could do whatever it is. Maybe it's like your heavy bench press or whatever it is, but you could pair that with like wearable resistance punch.
Absolutely. You do a squat, you do a loaded jump, you do an unloaded jump, you do a resisted or an unresisted jump or an assisted jump. Do the same thing with this. You can do a bench press, a plyometric push-up, a punch with loading on your arm, and then you can have a band holding in your arm and do an over-accelerated punch. And there you go. You've hit the entire force velocity spectrum within that. Love French contrast.
Yeah, there's so much unpacking that. Let's dive a little bit into French contrast to finish this up then, because No, Pete, it's just nice to jump into some more advanced concepts that maybe listeners haven't used, heard of, stuff like that. So you want to give us a little breakdown of what French contrast is, and then how to create a French contrast, I guess, set.
Yeah, cool. So as we've been talking here, it's French contrast training is pairing up similar muscle group exercises across a different range of loads and velocities. I'm not sure how layman that is. That might be more complex than I can think. But essentially, if you do a heavy squat, that is going to work on the contractile capabilities. That's going to work on your maximum strength. Then what you do is you go and you do a loaded jump. So what this will do is this will help increase your high relative force power out. Then you go to an unloaded jump, and that unloaded jump is going to increase the speed. So it's a more high velocity power output. And then finally, what you do is you do an assisted exercise, an assisted jump. And what this does is it means that your muscles can contract at a faster rate than they otherwise would be able to. So what this means is that your actin and myosin can overlap at a quicker rate, and then that's going to improve the neural capability. So your motor units are going to be able to fire faster. So you're going to get higher synchronization within the motor units. You're going to get higher activation within the motor units, and you're going to get higher firing rates within this set. So you can perform anywhere between 1 to 3 reps. It's usually power-based, kind of your set rep schemes. 1 to 3 reps for the heavy strength exercise, 3 to 5 reps for your jumps, and 5 to 10 reps for your assisted exercise. And there's no real set in stone set rep scheme, but that's the generally used one.
Nice. Whereabouts would you usually place this within a training cycle? Would this be similar to the oscillatory isometrics, where you'd have it closer to maybe a fight, or would you just be further back as you're developing maybe some more general capacities?
Yeah, so this would be something that I would put alongside the oscillatory isometrics in that kind of pre-competition phase. You'd want to make sure that you have established high eccentric, isometric, concentric strength capabilities prior to going into this. You want to ensure that you have had a few foot ground contacts with you in your jumping, that your muscles are able to produce force appropriately with this. So do some jumps first, do a couple of cycles or phases, training phases. And then as you're getting into a pre-competition phase, you're kind of 8-week out. You can use this. You can even combine the variable resistance using bands or chains within this as well. It's a perfect sequence for getting ready for a fight.
You've used flywheels extensively then for variable. Well, it's funny because they call flywheel training variable resistance, but a definition of variable resistance with flywheels is different to the definition of variable resistance with bands and chains, which, it's a pain in the ass having to explain that. But have flywheels been part of, I guess, would it be part of your preparation? And if so, why?
Yeah, so flywheels are great because they act with increasing inertia on the eccentric phase. So as we know, you're about 120 to 150% stronger eccentrically than you are concentrically. So flywheels are really good for improving that eccentric strength capability. So the stretching of the fascial tissues, of the tendons, of those passive elements, and then also the decoupling, the improved ability for the actin myosin to decouple. And essentially what that will do is it will improve both passive and active tension within the muscle. So that is contribution from your tendons and your connective tissues and of your actual muscles. But what's really cool, and something that I have a Ph.D. student looking at right now in rugby, is using it for neck strength. So a lot of the neck strength training that we find people doing is typically isometrics or is accentuated eccentrics. But the problem is concussions and head trauma or neck injuries usually occur in a dynamic sense. It's usually when you're getting hit or when you're hitting the mat or when you're hitting the ground. So this ability to have an increased dynamic or reactive neck strength is critical. So we're actually using the flywheel as a way to concentrically, you move it out, and then the inertia from it immediately will pull the head back into a position. So it's almost quasi isometric during that eccentric phase, because it's you're trying to prevent it from coming backwards, but it's basically super or over the maximum strength capabilities eccentrically, so it pulls you into there. So that's one of the things that one of the ways that we were really looking at flywheel as a novel training idea, as opposed to your typical upper and lower body uses of it.
Interesting. Yeah, actually, back in, was it 2018, I hooked up in Austin, Texas. I hooked up the Iron Neck with the 1080 Quantum and did accentuated eccentric with, I think it was 40 kgs of extra load, and just like holding the extension, pressing the button, and then letting it, basically doing a quasi isometric, just letting it pull me forward. And I was like, damn, I'm going to be so damn sore the next day. But luckily I wasn't. I must have been, I think since I'd already been training my neck at least, but I was like, I don't know if it's dumb or if it's smart or if it's something in between. Just like, obviously because the neck is a tender area. And if you start loading the shit out of it like that, it might not end well. But yeah, it's an interesting idea to use the flywheel with the neck training. Then would you use eccentric overload methods with that, like maybe a delayed braking action where you're kind of letting it come back and then quickly producing force to stop it? Or would you're kind of just coming out then just resisting straight away?
Yeah, so it depends on the training phase. So if you're doing neck strengthening, start out isometrically for longer holds, lower forces, so you can progress up to it. Then you can start working, the eccentric concentric coupling, and then accentuated eccentrics, and then finally you'd be ready for a reactive eccentric. And within that, it could be we could use it as a flywheel where you are pulling it straight out and then just resisting immediately, which would be a good first step. Then within that, you could be going out and then letting it come back to a certain point and then resisting. And then from there, you can do isometric holds with a partner with, dropping of the head. You'd see people do that for a hamstring development. So you got them bridged up on their back, you're holding their heels, they're in a prone position, and then you drop one leg, their muscles on the opposite leg have to turn on quickly. Same concept for the neck. So there's just a way to strengthen not only the muscles, but the connective tissues to protect that cervical spine.
Nice. No, that's some great info. Well, this podcast has been epic, Aaron. It's been a little over an hour now, so I don't want to take too much of your time. There's so much we can discuss, so we have to get you on again in the future. But thank you for coming on. I really appreciate it. If anyone wants to follow your work or find you online, where can they find you?
Yeah, so you can find me at Dr. Aaron Uthoff on Twitter or Instagram. You can look me up on ResearchGate to get a hold of some of my research. You can also email me at aaron.uthoff@aut.ac.nz.
Nice. I'll check those links in the description too. So if anyone's listening on YouTube or Spotify or whatever, it'll be there. But thanks for coming on, Aaron. Really appreciate it.
Hey, thanks for having me on, James. This is a good yawn, man.
Cheers.